Hello, today I want to talk about LON being transferred using IP protocols. Recently I was asked, do we have 3 LON IP standards? What shall I use? What are the differences and what is LON IP at all? The main question was, do we have now different LON over IP standards? But please let me introduce myself at first. I'm Matthias Lürkens, I'm Gesitech's CTO. I'm with Gesitech already since 31 years and I'm a communication specialist working with LON since 1995. For LONmark, I'm running the German marketing task group. As a member of the technical committee and as a delegate for the European CNTC 247 Working Group 4, I'm working on the standardization of LON. Right now the focus is on HDPLC and LON as the European EN 4908 with LON IP, HDPLC and RF communications. The main topic being discussed in this seminar is, do we have 3 standards for transferring LON over IP networks, and all being nicknamed with the same LON/IP. In fact, we already have 3 approved standards using IP protocol to transfer LON payload. Here I show just the ANSI CTA standards. In ISO IEC it is the 4908 collection and we have different standards names in China, Japan and other regions. Naming all of this LON/IP is the main reason for the confusion, but there are even more names for LON over IP networks. Since LON/IP is a nickname for all of them, we should be careful using that term. In the standards we usually find CNP for control network protocol, since LON as a trademarked term can't be part of an international standard. So we find CNP/IP, an IP852, a real LON IP without dash and slash in the middle, and at the end a CNP HDPLC. Furthermore, we have the different channel names you will find in the ISO commissioning tool, adding yet another alternative name for the underlying standard. If you now feel a Babylonian confusion, I'm with you. We are mixing standard names, channel names, nicknames and call them all together LON/IP. So in the next slides I will try to sort out the confusion and put some light on the different standards. I created a table for you mapping the nicknames to the approved standards, the name in the standard and what is the name of the LONmark channel, and additionally I added a few commands. Let us start with the first standard, which was really named LON/IP. It was started end of the 90s and was approved as ANSI 852, being now ANSI CTA 852. It is an approved standard in other regions worldwide and with ISO IEC 4908-4 an international standard. In ISO CT you will find IP 852 as a channel name for the version of LON over IP. In the standard definition you will not read LON but CNP for control network protocol as mentioned before. And really the ANSI CTA 852 standard does not refer only to LON as ANSI CTA 709.1 but additionally to CE bus as CA 600. So ANSI CTA 852 is from its origin a protocol independent transport layer. There have been some iterations of 852 ending with 852.1, which I want to explain later. Since its development, IT is developing pretty fast and much faster than control protocol. It was time to do LON on IP better, simpler and down to the neuron chip itself. It was started mid of the 2010s and the nickname is now really LON IP in small letters and without a dash. Usually a nickname is never official, and especially with ANSI CTA 852 the LON dash IP never was. The LON IP here is really used by Dialog Semiconductors, the owner of the LON technology. It is already approved in the US as ANSI CTA 709.7 and in Europe on the road as EN 4908-7. The name in the standard is still CNP IP, but that's a term in the paper only. In ISOT-CT you will find IP70 for LON IP using IPv4 addresses and IP100 for LON on IPv6. LON IP is defining a mapping from the LON domain subnet node address to an IP address. Through a router it makes all neurons, even in existing installations, addressable by IP, and yes, you can ping a neuron chip with an ICMP ping command. Furthermore, it defines how to exchange IP messages with a neuron chip. It makes a free topology TP-FT10 channel being an IP channel. The 6050 neuron chip is able to communicate with UDP message on a TP-FT10 channel. So LON IP is a dual standard for LON on IP in an IP-based network and for transferring IP messages on a TP-FT10 network. The newest standard having a relation with IP is ANSI CTA 709.8 using HDPLC, high definition power line communication, as a physical layer. In Europe it will be EN 4908-8 and the standardization procedure is running. We don't have a nickname up to now, so we usually call it HDPLC. The channel name will be HDPLC 40M for a network using IPv4 addressing and HDPLC 60M for IPv6. CNP HDPLC is a standard for tunneling LON on HDPLC powerline networks. It is not designed to be an alternative standard for tunneling LON in any kind of IP network. HDPLC as a powerline network has different qualities compared with an Ethernet network, since it is large area, self-organizing mesh, and free topology. You better compare it with RF or a multi-drop network. To address these characteristics, a new standard for LON layer 2, especially on HDPLC, was designed. So CNP HDPLC is not an IP standard, it is yet another LON layer 2 only. To discuss the issues and misunderstandings being raised by different methods to run LON over IP, let's go one step behind. LON is a protocol of 7 OSI layers, defying interoperability, and especially in IP networks we need to distinguish between interoperability and connectability. In an Ethernet network we have different PCs and maybe we are using different colors for the network cables. We can connect all of them with a switch and the PCs can communicate with each other using various IP protocols. So we have all PCs connected, but there is not yet automatically an interoperability achieved. Let me explain interoperability with voice over IP, and this time I will not use ZIP, H323 and other cryptic standards for telephone. I'm having Skype, I'm having WhatsApp and Facebook Messenger in my sample, since they are all coexisting on my smartphone. All three are using IP and all three offer similar service, running a phone and or video call over the internet. But you can't make a conference call with all three of them. They are simply not interoperable. The same issue you have with online meetings like WebEx, Teams, Zoom, GoToMeeting, TeamViewer and so on. You can't hook up into a WebEx using GoToMeeting and vice versa. So IP for the same kind of usage usually does not mean interoperability. LON is an interoperable protocol being defined by a stack of 7 OSI layers. As being discussed already in this presentation about LON on IP is happening on layer 2, the link layer. The interface between the link and the network layer is described with the NPDUs, the Network Protocol Data Unit format, which is identical for all link layers we have defined and approved for LON. And we have an LPDU, the Link Protocol Data Unit, usually encapsulating the NPDU, but most likely different for the different link layers. We have several different link layers defined for LON and a couple of different formats for the link layer protocol data units. So let's focus on the layer 2. We have some cable-related versions like the free topology TP-FD10 down to RS485 with the different baud rates. We have the old narrowband power line channels like PL20. And we have 3 standards using IP messages, 852, LON IP and CNP HD PLC. These 3 standards are using different media access methods and different LPDUs. So they are different layer 2 for LON and incompatible like a LON channel with TP-FD10 and another with RS485 on 39 kilobits, or like in the slide before, like Skype, WhatsApp and Facebook Messenger. But LON is routable since we have a common NPDU format between layer 2 and layer 3. So different layer 2, and we are used to name them physical layers, can easily be connected using LON routers. 852 usually was used to create backbones, even if the standard allows making devices. The routers connect usually TP-FD10 channels with a backbone, and since LON is an open protocol, it allows you to mix different vendors like using the routers from Gizitech, which is my company, the Smart Server IoT from Dialog Semiconductors, or the LRP from Leutek. And it's similar with LON IP, where are the routers connected with LON IP on the one side and maybe TP-FD10 in legacy mode on the other side, or in the extended LON IP mode, or what Gizitech can provide with a router from LON IP to CNP HD PLC. So if we are talking about LON over IP, we are just talking about yet another layer 2 for LON. I want to dig into the 852, which is the oldest one. It was standardized in 2001 and the definition started already end of the 90s. It is an IPv4 standard only, and it is tunneling LON messages, or more precise LON LPDUs, including the CRC like you have in the TP-FD10 network. It's using unicast addressing for IP, multicast addressing is optional. It needs a configuration server to build up the channel, which consists of up to 256 members, which is not that much nowadays. The configuration server is a piece of software either running on a PC or inside of an IP852 router. The configuration server builds a list of devices with their IP and LON addresses and distributes that list to the routers or devices being member of the IP852 channel. IP852 provides NAT support, so a device can reside behind a firewall with IP address translation and IP port mapping. So you can build an IP852 channel which is spread all over the planet. IP852 implements aggregation, meaning that multiple LON packets are put into a single UDP frame. Keep in mind that IP852 comes from a time when IP networks had not been performed as we know today. Furthermore, LON messages usually are pretty short, and IP is not well designed for short messages and the request-response services on short messages. IP852 supports authentication with MD5, which is yet an outdated algorithm. IP852 has a large installed base of 100,000 of devices, mainly routers, so it will survive for a long time. There are some disadvantages like the limited number of the devices and the configuration server, which is a single point of failure and not that easy to use. IP852 does not really like DHCP, since a change of the IP address affects the mapping of LON addresses to IP addresses. And we already recognize that MD5 is outdated and it does not offer encryption. For the developers, IP852 is complicated due to the handling of the channel list and the need to create a configuration server. Nevertheless, IP852 is the most used standard for tunneling LON over IP right now. IP852.1 was a successor for IP852. It addressed some weaknesses of 852 like a better DHCP and NAT support, larger channels or SHA-2 based authentication, and it added already IPv6 support. But due to the large installed base of the initial 852 standard, it was never really adopted and I have no knowledge about devices using 852.1. Thanks to Sam Smith, one of the fathers of the IP852 standard, who wrote the article including these highlights of 852.1. LON IP was developed by Echelon in the 2010s and is one of the main parts of the ISOT strategy. It supports IPv4 and IPv6 on an IP network. The standard calls that part of LON IP CNP IP AN, being Control Network IP Automation Network. LON IP defines a mapping between the LON and IP addresses, so it provides an IP addressing scheme to access a LON device and even existing devices using an IPv4 or IPv6 address. LON multicasts are mapped to IP multicast, so it can't be passed through a NAT router. Networks at different locations need to be connected by VPN, which is easy today but wasn't really available when IP852 was created. So it does not need a configuration and master device anymore, wiping out a single point of failure. LON IP brings IP support for the neuron. The standard names that CNP IP CN, which is Control Network IP Control Network. It defines how to transfer IP messages on a TP-FD10 channel down to a neuron chip, and it makes the TP-FD10 channel a real IP channel. The Neuron 6050 now has a tiny IP stack implementing ICMP and DHCP services. LON IP supports DHCP. It extends the transaction ID for request response or ACT services from 4 to 12 bit. It is fast, easy to implement, and pretty tiny. So it is really an up-to-date IP standard for a control protocol. You may implement routers, but due to the simplicity, you can create devices easily too. There are some disadvantages, being mainly the lack of encryption and authentication. LON IP is using UDP, and there is still up to now no real standard for UDP like TLS for TCP. DTLS might be an option until it is better standardized and adopted by the suppliers of embedded software. Due to the fast standardization procedure of IT and the overall need of a UDP encryption and authentication, a solution will be available. It does not make sense to implement alternative solutions inside of a specific control protocol. LON IP will just take advantage of the emerging capabilities of IT standards. You may have IP address collisions if you run a LON IP network in a 192.168 or in a 10.xxx IP network, but you can avoid that kind of issues running the LON IP devices in mapped address mode. CNP HDPLC is a layer 2 for HDPLC. It is not a new LON on IP standard. You can use it for backbones and devices. We just use IP messages as a transport medium on HDPLC since IP is the generic transport layer of an HDPLC network at all. It is not intended to use CNP HDPLC on an Ethernet channel. We provide up to 1024 devices per channel, which is 4 times more than on IP852. HDPLC requires a master device building and controlling the HDPLC network. There are options to build networks with redundant masters. And there is a master function necessary for LON over HDPLC, which is usually implemented in the HDPLC master device. HDPLC is more designed for performance streaming like audio or video, but not for messaging ping pong, and we have in LON request response or ACT service types. So we added aggregation for LON over HDPLC, which is furthermore increasing efficiency in case of short LON messages. We don't need to have IP address set up, just the HDPLC master needs to have a unique and known IP address. All other HDPLC devices may have the same IP address and do not require an address setup. That once again is a hint that CNP HDPLC is not an alternative LON over IP standard. HDPLC provides encryption with AES 128 and with a pairwise key being shared between all devices in the CNP HDPLC channel. You can implement using the pairwise key to control the access to the network and to authenticate. Once again, CNP HDPLC is not a LON IP standard. It is a layer 2 for HDPLC high-definition powerline networks to take advantage of features like large distances, being media independent, large number of devices, encryption-free topology, and more. You can use other IP applications like CCTV, edge gateways, and more together with CNP HDPLC on the same powerline network. Everything which needs to have an RJ45 for Ethernet somewhere can be used in parallel with LON in the same HDPLC network. And yes, there are some disadvantages for that standards too. There's a master as a single point of failure, but there are methods for building redundant masters. And we have a latency of a few hundreds of milliseconds, which is reasoned by HDPLC being a mesh technology for large area networks of tens of kilometers distance. Again, this makes clear that CNP HDPLC is a special layer 2 and not third LON over IP standard. So let's do the conclusion. IP852 is legacy but has a large installed base, mainly with routers in backbone channels. Due to the large number of installed devices, we will see it at least for the next 2 decades. LON IP is the actual LON over IP standard. It provides generic IP addressing down to the neuron chip, making all LON devices being IP addressable. It introduces IP features on the 6050 neuron chip for the TP-FD10 channel, and it adds IPv6 support. LON IP is the recommended standard for all new applications. CNP HDPLC is a layer 2 for HDPLC networks, and it does not compete with IP852 or LON IP. It should not be used without HDPLC. You would need the HDPLC master function somewhere. You need to consider some manual setup which is done automatically in an HDPLC network by HDPLC network services, and at the end overall performance is lower than on IP852 or LAN IP. So use it for HDPLC only. Yeah, that was the seminar for today, and I hope it answered some questions about LON over IP, IP852, LON IP, and LON over HDPLC. Please keep in mind, if you are talking about LON IP, do you really mean LON/IP, IP852, LON IP as a single word in lower letters without any dash, slash or something? And for me, who I am member of the standardization committees, usually I don't talk not in nicknames but in the standard names. So it is 852, 709.7 and 709.8, or it is the 4908-4, 4908-7 and 4908-8 standards. Usually it's not easy to speak, but that makes it quite clear what is meant and what is used. Thanks. Please be invited to send questions to my email address, and I thank you for your audience.